Let us see another example of a precipitation reaction. When we mix potassium iodide and lead nitrate, we will get a precipitate lead iodide, which is the precipitate, that is the solid form. And all other compounds are in AQ. You can see that one. So that means all are soluble in water except our lead iodide here, correct? So how we will know which one is going to be a solid or a precipitate when two aqueous solutions are combined? For that one, we have to know a solubility chart, which is your reference material, and you should know how to read that one. So here is an example chart for the solubility rules. You may have a different one in your reference material, but in basically how to read that one is compounds contains lithium ions, sodium ions, potassium ions, and ammonium ions are always soluble. Okay, always soluble. There are no exceptions for these ions. Say for example, if you are putting an ABr, K2SO4, ammonium carbonate, all these salts are going to be soluble in water. And another example, let us take NO3 minus and acetate ions, always soluble. Okay, there are no exceptions here either. So let us see another example here, chloride, bromide, and iodide. These are mostly soluble, not always soluble. There are some exceptions. We have already seen AgCl is insoluble, and in the example we are discussing now, the lead iodide is insoluble, right? So that is how it is going to be helpful. The solubility chart is going to be helpful for you to decide, okay, which salt is going to be insoluble, which salt is going to be soluble in water. So you can always refer to this one, all right? So going back to this equation here, let us see how to write the net ionic equation for this one. Okay, so you can see the particle diagram. In the particle diagram, it is showing potassium iodide coming from the pipette here, which is actually magnified here. The ions are magnified. This is the particle diagram, potassium ion and iodide ion, combining with the ions already present in the solution, which is lead ion and nitrate ion. You are getting a precipitate, that's a yellow precipitate forming here from lead ions and iodide ions, and NO3 ions and potassium ions are floating around in the solution. So we will write the equation for this reaction. So the equation is potassium iodide Ki, which is going to be soluble in water, because we have seen that K plus ions combining with any other negative ion, that is anion, it is going to be soluble. So we will write AQ, potassium iodide combining with the lead nitrate, PbNO3 twice, which is also all nitrates are always soluble. Whenever NO3 minus is combining with any positive ion here, it's going to be always soluble. So I will write AQ. That gives you the products are K and NO3. So NO3 minus and K plus. So KNO3 plus 1 and minus 1 will cancel. And PB and I, we will write PB I2 because PB is negative. Sorry, here it is 2. So that means when you take it to this side, it will be PB plus 2. So this one will be plus 2, this will be negative 1. So if you don't remember how to write the formula, please go ahead and watch how to write the formula for compounds from bonding chapter. So here it is IUPAC nomenclature. So here it is PbI2 formula. So this is the equation, molecular equation. Is it balanced? Not yet. We can see how to balance this one. You can see the number here, potassium 1, and I1 and but we have I here too, right? So how to make 2? By putting a coefficient 2 here. So we have 2 potassium now. So how to make 2 potassium here? By putting a coefficient 2 here. So now it is balanced 1 Pb, 1 Pb, 2 NO3 and 2 goes for NO3 here. So now it is balanced. That is our molecular equation. How can we write the complete ionic equation? So we will write K plus, because it is AQ, we can split that one into ions. But can we just write K plus? No, we have two of them. So I have to write 2 here because the mass and charge should be balanced, right? So plus, this is again AQ, so I can split it into ions. So Pb 2 plus, because as I said, the 2 is the charge for lead here, and NO3 minus, how many we have? We have 2 of them. Gives you again 2 potassium here because the coefficient is 2. So we have that 2 goes for NO3 as well. So then PbI2 was the solid, right? So PbI2 we will just write as such. We cannot split that one. And now we will look for the spectator ion, which is same on both sides. So I have 2K plus, 2K plus, 2NO3 minus, 2NO3 minus. So these are the spectator ion. And now I can write my net ionic equation, which are the ions on the left side. I will just write that one down here. And the ions on the right side, oh, there are no ions on the right side. We have a solid precipitate here, which is PbI2. Because ions on the right side got cancelled, they are the spectator ions. So we got the net ionic equation here. So that's how we are writing the net ionic equation for precipitation reactions. Now you can try writing a net ionic equation for the reaction between sodium sulfate and barium chloride and check your answer. You must have these equations in front of you now. The molecular equation Na2SO4 plus BaCl2 gives you 2NaCl plus BaSO4. That is the balanced chemical equation. So then you must be having the complete ionic equation 2Na plus because there is a subscript 2 here, and then SO4 2 minus, and Ba2 plus because barium is charge is 2 positive, and there are 2 chlorine, so 2 Cl minus, right? And then here 2 coefficients, so that 2 goes for Na as well as Cl, so 2 Na plus and 2 Cl minus. And then BaSO4 solid, we cannot split into ions. So you must be having the spectator ion crossed out, and you have the net ionic that looks like this, right? Good job. Let's see another example. Write net ionic equation between sodium hydroxide and hydrochloric acid. So it is very clear that it is written hydroxide, so that's a base. And it is written hydrochloric acid, so that is an acid. So this is a reaction between acid and base, so which is acid-base reaction. You will get salt plus water. That means acid is getting neutralized by base. So we are going to write the neutralization reaction for sodium hydroxide and hydrochloric acid. So let us see how to write the net ionic equation for this reaction.